Hello class, welcome back. Today we're going to continue our discussion about variables and expressions, focusing a little bit today on floating point numbers. Then we'll take a look at some calculations and finally wrap it up with the concept of casting. In the next video, we'll take a look a little bit into strings, characters, and the scanner, and that should set you up pretty nicely for completing all the assignments and labs for week 2. So from last week, we have this slide that we talked about briefly, showing the different variable types, the primitive variable types that we use in Java. We have looked at byte, short, int, and long, all the integer data types. We talked about Boolean, which is your true-false data type. And today we're going to focus on the float and the double. Float and double are the decimal places, the ones where we can hold fractional data or, decimal numbers. Something other than a whole number. And again, similar to integers, you have to declare a variable, give it a name, and initialize it to a value before you can use it. So let's take a look in Zybooks, and we'll hover over to the floating point chapter. And it gives a nice little explanation of what a floating point number is. We're going to be using double in this class predominantly for floating point numbers, and we'll probably be using integer types, int, for integer types. It does talk about the scanner, and we'll talk about that in another video, but we don't need that for now. So a floating point number, quite simply, is a number with a fractional part, something like 3.5 or 4.2 or something else. So since we have multiple variable types, integer types and floating point types, you need to decide when you want to use each type of variable. So integer types are good for counting things. How many phones do you own? How many computers do you own? How many cars do you own? Those are whole numbers. You either own a car or you don't. You own a phone or you don't. Very countable items. Fractional items, such as temperature, for example, can be fractional. The length of something, the speed of something, these can all be fractional items. They would be good choices for floating point numbers. And if we scroll down a little bit in Zybooks, it has a nice little chapter for, nice little section in the chapter for when to use double versus integer. And again, integer values are good for things that are counted. Floating point values, variables, are good for measurements and dealing with fractional items. So let's take a look at an example and how we can define and declare a floating point number and see what it looks like when we print it out. So we'll head back to our test area in chapter 35, and we'll load up the Coding Room's IDE. We'll scroll down, we'll wait for it to load, and we see, well, here is our testing from last week. We will take that out because we don't need that right now. I'll leave the print line because that's always fun to have. So we can declare a double, and we can pick anything we want. Let's pick current temperature equals, at the time of this book, it is 67.8 degrees outside. And we print it the same way we print anything else. Temperature is, and then we can do a current temperature. And we'll put the semicolon at the end, and we'll clean it up and get rid of these extra blank lines. And we'll run it, and hopefully I didn't make any typos. Great. Works just like any other variable we've seen so far. We can do a little bit of calculations with it too. We can say current temperature equals current temperature plus 3.27. Just picking numbers at random here. And when we run it again, we'll see the change in the value. 71.07. Okay, great. So we know math works, and we know we can use decimal numbers. So that's interesting. So why don't we now take a look at how we can use integer types and floating point types and the different operators that are available to us. We looked at that yesterday briefly when we looked at the order of operations slide, which you can see here. We can look at the times, divide, and modulo, the plus and the minus. We'll take a look at those 5 now. We'll write some examples so you can kind of see how they work. And that will lead us into our final topic, casting. Okay, so back we go to our test area, and let's really clean it out this time. Let's get rid of all this extra stuff we don't need, and we're going to start with declaring a new variable. We're going to start with an integer variable, and just for the sake of this demonstration, we'll call it int var, and we'll set it to 0. And then we're going to create a double, and we'll call it double var equals 0. Set them both to 0. Now you may be thinking, oh, wait a second, you're setting a double to a integer value, 0. 0 is an integer value, it's a whole number. Well, let's see what happens when we print it. And we'll put in our typical print statement, and we'll give it a run. Pull this up a little bit, give us a little more room. And we'll run it, and it says 0.0. So you can store an integer value inside a double. It simply makes it a decimal value with the 0.0 at the end of it. That is part of casting, and again, we'll talk about casting in a minute. So, we are probably going to need multiple integer variables, so we'll declare more. Int var 2 equals 0, and we'll declare a third one. Int var, what do we call it? Total equals 0, just so we don't have variable 1, 2, and 3. That would look kind of silly. And we'll do the same thing with the double. We'll create another double var here. We'll create another one equals 0. And more accurately, we probably should put the 0.0 in there to properly initialize it, even though it does work the other way. And we'll set up the total as well. Let's scroll down. So, the first two operations we have are the fairly simple addition and subtraction. If we set int var total equal to the value of 2 plus 4, we'll just add some numbers in there. And this is your basic assignment statement. You have the variable name on the left and the calculation on the right. And we'll print out int total is, and we'll add in our int var total. Now I know this is a very basic example, but we're going to get a little more complicated in a minute. And I'm going to comment out this line because we don't currently need it. So remember, with comments you have the single line comment, and we're going to use that here because it makes the most sense. Okay, so if I run it, our total is 6, which is exactly what we expected. If we wanted to put a comment in here, total is 6. Better yet, why don't we change it to result? Result is 6. What if instead we wanted to do a subtraction? Well, we can do it right afterwards. Equals int var total minus, 72. So if we do this math and we see the result is, what do we think it's going to be? Well, let's run it and find out. Minus 66. And we'll put that in there for reference. Next, we can take a look at the multiplication. And why don't we make it up back to more simple numbers again? How about 5 times 7? And we know the result will be 35. And we'll run it and we'll see that multiplication works as we expect. Now let's have a little fun. Let's take a look at division. Equals 10 divided by 3. What do we think that's going to be? The result is, well, we think it should be 3 1/3, right? 3 goes into 10 3 times with 1 left over, so 3 1/3. So the result would be 3.333, etc., etc., etc. Let's see what the result is when we print it. Answer is 3, which is kind of curious, isn't it? We would have expected it to be 3.33, but remember, this is an integer type. Integer types can only store integer values. So by design, anytime you do division and you're dividing integers and you lose the decimal point, it doesn't round it, it drops it. So if we did something, trying to think of something offhand here that would give us a higher number. If we did, let's see, 10 or 5 divided by 4 would be 1.2. No, that's not good either. Well, 5.2. That would give us 2.5, which should round up. But you'll see when we run it, oops, I forgot the semicolon. Yeah, I do make a lot of typos. But that's okay. It's easy to fix. The result is 2. So it does not round. It drops. If we do similar values for doubles, and I'll just replicate everything here, 2 plus 4, and I am temporarily going to comment out this print statement because we don't need to see the printing of the integers, but now we want to see the printing of the doubles. So all these integer calculations are still going to happen. We're just not going to display the output. So if I run, and I want to make the output consistent. Oops, too many is's. Get rid of 1. Okay. Double var total. There. So if I run this, lost my run button. There it is. 6.0. So again, we added the 2 integer values to get 6. We made it a double, so the double is represented as 6.0, and I have an extra D. Let me get rid of that. We can do the same thing again with the second calculation. Oops. Fix that, run it, we'll get minus 66.0. Why is it not running? Okay, there it goes. It just took a minute. Okay, so I made a typo. Let us see. Cannot find symbol. So that's a new error first. Cannot find symbol. And what it's pointing at is the beginning of the symbol it does not know what to do with. In this case, the symbol is a variable name. And if you look at it, you'll see that I have double var total equals double var total minus 72. But you'll note that the T in total is not capitalized. Case matters when it comes to variable names. So we'll fix that T, we'll give it a run, and there's our double total minus 66.0. Double var total equals 5 times 7, expecting 35.0, and it worked. Now, let's take a look at this. Our 5 divided by 2. In the integer world, when we did this calculation, we got 2. Now, I am expecting to see 2.5. It's not running again. All right, so let's just do a quick refresh here and reload the whole environment. The good thing about zyBooks is when the data is entered into your lab, it's saved automatically, so you can do a refresh like this. But if you're not sure, it's always a great idea to copy the code, save it to a text editor of some sort, just so you have it and it doesn't get lost. Sometimes these online IDEs get a little wonky, like right now we're having an issue. Don't know if it's my computer because I have a ton of windows open or something else, but anyway, let's try running it now and see if it runs. And it's still not. There it goes. Okay. Our double total is 2.0. Interesting. We were expecting 2.5. Well, since we're dividing integers, it's doing the division as integers. So when we do division as integers, it is saving it as an integer and then storing that into a double. So it doesn't do the conversion that we were just expecting. That is where casting is going to come in to help us. Now, some languages will automatically do it for us, like Python. It will convert the data to whatever data type it is at the time. So remember, Python is not a strictly typed language. It can be any type of variable, can hold any value. Java is a strictly typed language, so you do have to declare the variable type at the time you declare the variable. So jumping back over to our slideshow, I do have a slide about changing variable types, which is called casting. Casting can be done in one of two ways, implicit and explicit. Implicit was when the Java interpreter determines that a variable change in type is necessary and would automatically do it for us. Explicit casting is where we want to tell the compiler or the interpreter, no, I want you to make this variable a float and then do the division, which is what we want to do in the prior example. So we're going to take a look at the explicit casting. Implicit, we really don't need to worry about too much because it does it for us. It's the explicit one that we want to take a look at. Okay, so let's jump back over to our example and we'll see if we can do some casting and converting and see how that performs. So let's set up for us a integer variable. We'll use int var1. We'll give that the value of 3, and we'll have double var1 equals about 100.0, and we'll do a little math. We'll give it double total, double var total equals double var1 divided by int var1. And I will now take our line 29 and I will put it down here so we can get the answer printed for us. And clean it up a little bit, get rid of these extra blank lines. Now, we're taking a double value, 100.0, and dividing it by 3. So a double divided by an integer. When I run this, the total is 33.333, and we get a 6 at the end here, which we know isn't right. That does have to do with floating point rounding. And the reason is when you store values inside of a computer, it can't store the decimal portions exactly. It's an interpretation. So not too much to worry about with that. When we do our printing and our calculating, the error or the lack of precision is usually so far down the chain, it's really not going to affect anything we're doing. In more scientific applications, this is something you'll need to account for. But for now, for this class, it's not anything we really need to worry about too much. Okay, so we divided a double by an int, and we have our result. What if we did int var2 equals 100? And let's just do int var2 divided by int var1 instead. So we'll mix it up, which is similar to what we have up here. And we run it again. This time, instead of saying 33.333, we're going to see 33.0, and here's our answer. So this is where casting can come in. I know this is a double type, because that's what I declared it as. I know these are integer types. So we can make the compiler do the calculation as an integer as a floating point number by simply doing something like this. Putting in parentheses the data type that we want to convert it to or cast it to changes this int var2 to a double. So this now int var2 of 100 is now converted to 100.0. So dividing a double by an integer, as we saw before, gives us a double as a result. And if I run it, there's our answer. So this is how you do your conversion. You don't need to do both variables, although we could. And we should see the same response. And there it is. But just doing one is sufficient. I'll take out the extra one. Okay, great. So we saw something about converting. Let's see if we can go the other way with it. Let's comment out this, and we'll leave it be for now. And we'll go back to our integer section. And let's do int var total equals double var 1. I think we have to set the value for that, divided by 3. So let's set the value for that first. Double var1 equals, well, let's go good old 100.0 since we're sticking with that. We might as well continue. So if I run this, 100.0 divided by 3. So this is now giving us an error. It's more of a warning, but it's an error. It's telling us that since it's doing a division of a double by an integer and storing the result in an integer, that we could be losing data. And we would lose the 0.333, the decimal points. So this is telling us that you don't want to do this because you're going to lose data when we convert to from a double to an integer. You cannot store a double value in an integer. You can do it the other way around. You can store an integer in a double. So we can get around this, and it's probably not a great idea to do something like this, is to convert the double to an integer and then do our division. 33, which is correct. However, if we had something like 101, which the answer should be 33.6667, we're still getting 33. So it's not a great idea to convert from a double to an int. You can, if your program requires it. It is okay to go double, integer to double. That doesn't lose data. So the idea is when you go to convert and cast, that you want to make sure that the values you're converting from and to are compatible. Going back to our slide for a second here, you can basically convert upwards or down the list from byte to short, short to int to long, long to float, and float to double without having to tell the compiler. When you want to go the other way, double to float or float to long or long to int or any of those other smaller combinations, whenever you go bigger to smaller, you're going to get the error. If you go smaller to bigger, you're okay. So that leaves us with one type of calculation which we have not seen yet, is the percent, the modulo. If you think about division, when you do a division, an integer division, you get a quotient and a remainder. With integer division, when you use the divide, this typical divide sign, that gives us the quotient. Well, with modulo, that gives us the remainder. The percent will give us the remainder. So let's take a look at some examples of that. Back to our example over here. We're going to comment out these statements because they're just going to be in the way for now. And we are going to try a little experiment. I'm going to comment this out this line also, and we are going to put it at the very bottom. And we're not going to use variables so much as we're going to use hard-coded values, which, as I said, is not a great idea, but for the purposes of this modulo example, I think it'll work out just fine. So let's just go with a print statement. And why don't we pick some easy numbers? How about 7 divided by 3? 7 slash 3 equals, oops, that's not an equals, that's an equals. So that's just text, that is not a formula. And now we're going to put in, well, why don't we do int var total, after all. And above it, we'll actually do our int var total equals 7 divided by 3. Yeah, we'll do it the right way. There we go. So int var total, 7 divided by 3, should be 2 1/3, 2.333, but we're using integers. So since we're using integers, we lose the decimal point. I'm expecting to see this print the value of 2. 7 divided by 3 is 2. And now, I'm going to create another variable. I'm going to scroll back up. And I'm going to do int var remainder equals 0. Int var remainder equals 7 modulo 3, right? So this is the opposite. This is if the int var total gives us the quotient, and the int var remainder with the modulo gives us the remainder. So let's create another print statement. 7 modulo 3 equals, and we'll add in int var remainder. And I'll put over here quotient. I can spell quotient. And over here I'll put in remainder. And I do need a semicolon over here, and I almost forgot. Let's put that in there. And we'll run it, and we'll see our output. And there it is. So 7 divided by 3 in integers is 2, and 7 modulo 3 in integers is 1. So we're able to get our quotients and remainders, and this is quite useful when it comes into converting things from bigger quantities to small, such as how many nickels and quarters and pennies and dimes are in a dollar amount. If you have $5.73, how many quarters is that? How many nickels would that be? How many dimes? And there's some examples. We'll take a look at that at another time. But those are the kinds of things that we can do with the module. Anything where you would need the remainder is a great thing to have. Also good for checking for something if it's divisible by 3 or not, or divisible by any other number. If the modulo response is 0, you know there is no remainder, so it's divisible by whatever you want to test it by. So 7 divided by 3, we know does not go in evenly. What about, which we just do something like system.out.println, and we're just going to do, we'll just do a quick calculation in here. How about 99 modulo 4? Is 99 evenly divisible by 4? Well, it shouldn't be, because we have an odd number divided by an even number. There should be a remainder. And let's see. So there's a remainder of 3. So we know that 4 does not evenly go into 99. If we change this to 3 and run it, the remainder is 0. So we know 3 does go into 99 evenly. And that's one way we can do some quick math calculations. Okay, so we have modulo, we have divide, we have times, multiply, we have an addition and subtraction. I will wrap this video up now. We're just at the 30-minute mark. So take a look at it, do some practicing with the different calculations and the different variable types, get a feel for what they do. If you get something that you don't expect and you're not sure why, send me the code snippet. I'll take a look and I'll give you some feedback. Next up, we will take a look at strings, characters, and the scanner, because we're going to need that for our lab. So that will be our next video coming soon. Anyway, practice this, and I will see you all next time.